The inverse tangent function. Once again, like we talked about in the notes on 5.3 and 5.5, the inverse tangent has all these cycles that go on forever and ever in both directions, and it fails the horizontal line test also. So its inverse will also not be a function. It fails to be that because of the horizontal line test. So we have this domain of all reals except odd integer multiples of pi over 2 and range all reals. We want to go through the same three criteria we did before. We got to keep the range the same. Well, so we want to keep all reals. We want to um, we want to contain all the values between 0 and pi over 2. Obviously, we can't include pi over 2 because that's an asymptote. We also want it to be a continuous group of values, so we're going to choose this group right here from negative pi over 2 to positive pi over 2. So that's what we've done in our criteria. We went through and we chose. Please make sure you understand I'm using parentheses and not brackets because you can't include those because those are asymptotes. Those are non-existent values. At pi over 2 and negative pi over 2, the tangent, the slope of the line does not exist. Okay, so you can't include those. That's the only difference in the range of the inverse tangent function from the inverse sine function. So inverse tangent goes to the right half of the circle, but in a slightly different way than you might expect. So we're dealing with one cycle of the tangent function, and it is a really big deal that you not include the endpoints. Here's the inverse tangents picture. We got these horizontal asymptotes and one cycle that goes through the origin. Now the difference between the tangents, well, we're not following x values like we did for cosine. We're not following y values like we did for sine. We're following the slopes. And so those slopes go to the right half of the circle. So for instance, tangent inverse of radical 3 over 3. Well, that takes me to pi over 6, right? The angle measurement with a slope of radical 3 over 3 is pi over 6. And these compositions, if you start with 7 pi over 6, it's going to send you through the origin, right? Because you have to follow the slope to get to pi over 6. Likewise, if you do tangent inverse of tangent of 2 pi over 3, it's going to slide through the origin, but you can't call it 5 pi over 3, remember. You have to call it negative pi over 3. So that's the big difference with tangent. Tangent isn't going along x values or y values. It's following slopes, and it's going right through the origin. But everything is going to end up on the right half of the circle because all of these answers right here have to be between negative pi over 2 and positive pi over 2.